So hello everyone, how are you? Welcome again to our YouTube channel Engineers World. So this is the lecture series of RCC, and in the last lecture we studied about various assumptions of working stress method. Now in this lecture we will solve some important previous year's GATE numericals. So previous year's GATE numericals. / questions. So, starting with the first question that will be coming on your screen. So the question says, the basic assumption of the plane section normal to the neutral axis before bending remains plane and normal to the neutral axis after bending leads to option 1 is uniform strain over the beam cross section, option B is uniform stress over the beam cross section, option C says linearly varying strain over the cross section, and option D says stresses which are proportional to strains at the cross section. Now this question came in GATE 1995 and it was of 1 mark. So it is simple that the basic assumptions of plane section normal to the neutral axis means linearly varying strain over the cross section. So our option C is correct, linearly varying strains. So this was the first numerical, not a numerical, it was a conceptual question based on assumptions. Now coming to the second question, your question number 2. So question number 2 says the modulus of rupture of concrete gives. The 4 options on the screen are direct tensile strength of the concrete, second is the direct compressive strength of concrete, third option is the tensile strength of the concrete under bending, and fourth option says the characteristic strength of the concrete. We know that the 2-point load test gives us or 1-point load test gives us the modulus of rupture, and that is 2 for the tensile strength of concrete under bending. So the option C is correct. That says tensile strength of the concrete under bending. Tensile strength. Now, moving on to the next question, that is third question. So the third question says, it will be displayed on your screen. The cylinder strength of the concrete is less than the cube strength because of, so the options are the difference in the shape of the cross section of the specimens, second is the difference in the slenderness ratio of the specimen, third option is the friction between the concrete specimens and the steel plate of the testing machine, and the fourth option is the cubes are tested without capping but the cylinders are tested with capping. This question came in 1997 and it was also 1 mark. See the question, when we perform the cylinder strength of concrete and parallelly we perform the cube strength, we find that the cylinder strength or cube strength is around 1.27 times of cylinder strength. What is the reason? The reason is the friction between the concrete specimen and the steel plate of the testing machine. So more friction is generated in cube, that's why it shows more strength. So our option C here is correct. So this is all about third question. Now moving on to the next question that will be displayed on your screen. The next question says, yeah, it's very interesting. The characteristic strength of concrete is defined as that compressive strength below which not more than, first option 10% of results fail, second option 5% of results fail, third option 2% of results fail, and fourth is none of these. As I already explained you in the very first lecture, that characteristic strength of a concrete is defined as compressive strength below which not more than 5% of test results fail. So our option B is correct. Now moving on to the next question, that is our question 5. So in question 5, he asks, as the provisions of IS 456-2000, the short-term modulus of the elasticity of M25 grade concrete in Newton per mm square can be assumed to be. The options are A 25,000, B 28,500, C is 30,000 and D is 36,000. This question came in 2002 GATE and it was of 1 mark. We know that the formula of short-term modulus of elasticity of concrete is given as 5,000 root of FCK, where FCK is our characteristic strength, and he has given as M25 grade, so here FCK will be 25. On substituting the values, we'll get 5,000 root 25, and which further gives 25,000 Newton per mm square. So our answer goes with A part 25,000. So A part is correct. So this was the numerical on short-term modulus of concrete. So moving on to the next question. So the next question says, the target mean strength FCM, he has represented it by FCM, for concrete mix design obtained from the characteristic strength FCK and standard deviation sigma as defined in IS 456-2000 is, option 1 is FCK plus 1.35 sigma, second option is FCK plus 1.45 sigma, third option is FCK plus 1.55 sigma, and last option is FCK plus 1.65 sigma. This question came in GATE 2014 in set 2 and it was of 1 mark question. As I already explained you the formula of target mean strength, that is FCM, he has represented target mean strength by FCM. It is FCK plus 1.65 times standard deviation. So this is the formula for target mean strength. So our option D is correct. Now moving on to the next question. This question also came in GATE 2014. It was a 1 mark question and it came in set 2. The question says the modulus of elasticity E equal to 5,000 root FCK. E equal to 5,000 root FCK. We know that is the short-term modulus of elasticity, where FCK is the characteristic compressive strength of concrete specified in IS 456-2000 is based on. Here are 4 options. First is tangent modulus, second option is initial tangent modulus, third option is secant modulus, and fourth option is chord. As in one of my lectures, I already explained you that the short-term modulus of elasticity is nothing but the secant modulus. So here our option C is correct. So this was all about question 7. Now moving on to the 8th question. The 8th question is a numerical data type question, and this was a 1 mark question in GATE 2014 in set 2. The question says the flexural tensile strength of M25 grade concrete in Newton per mm square as per IS 456-2000 is. See, we know that the flexural tensile strength is nothing but FCR, modulus of rupture, and its formula is given as 0.7 under root of FCK, where FCK is the characteristic strength of concrete. See, in the question he has given M25 concrete, so our FCK will be 25. So on substituting the values, we will get so our answer will be 3.5 Newton per mm square will be our flexural tensile strength. So this was a numerical data type question. Now moving on to the next question. Our next question says the modulus of rupture of concrete in terms of its characteristic cube strength in MPa according to IS 456 2000 is. This question came in GATE 2009 and it was a 1 mark question. The options are 5000 FCK, second option is 0.7 FCK, third is 5000 FCK, root FCK, and our fourth option is 0.7 root FCK. So as I already explained you in previous numerical, that modulus of rupture FCR is nothing but the 0.7 root times the characteristic strength of concrete. So our option D is correct. Now we will move on to the last question of today's lecture. Our last question says, as per IS 456 2000, in the limit state design of flexural member, the strain in reinforcing bars under tension at ultimate state should not be less than. So our options are, first is Fy upon Es, second option is Fy upon Es plus 0.002, third one is Fy upon 1.15 Es, and fourth option is Fy upon 1.15 Es plus 0.002. This question came in GATE 2012 and it was a 1 mark question. See, in previous lectures I already explained you while explaining the stress strain curve of cold worked HYSD bars that the ultimate strain in reinforcing bars under tension at ultimate state shall not be less than Fy upon 1.15 Es plus 0.002. So our option D is correct. So this was all about today's lecture. Today we solved some previous year's GATE numericals which were related to the topics we have studied till. Hope you would have liked the today's lecture.